Hey there everybody, today we're going to be creating a binary tree just like this using Pygame and Python. So this is very useful. You can use a bunch of different algorithms on this such as depth first search, and I'll actually have a video on that in a little bit about how to code that up. Breadth first search is another one, but this is a very common structure within data science, so it's something great to know and know how to build. So let's get right down into it. So the first thing we're actually going to do is first off import Pygame. Then we're going to go ahead and create a few different variables that we're going to need, such as the width of the screen. So we're just going to create a square window. For this reason, we're just going to need the width. And then we're going to need to initialize the window itself. Pygame display set mode. And then it's just going to take in the size of the window. It's just going to be width in this case. And then we're just going to create ourselves a little bit of a caption here just so we can actually go ahead and actually create a little bit more of a customization of what we have here. So we're just going to call this binary tree. A few other things we're going to do real quick is we're actually going to create just some constants for colors. Makes it a little bit easier. We're going to do is one for now, which is just going to be black, which is just all zeros. So it's just a red, green, blue, RGB color values, red, green, blue, all being zeros. Alright, now that we got a lot of these variables set up, the next thing we can do is actually go ahead and create a main function. This is just going to be what we're going to call right away, just so that we actually have something to actually run our window and create our window and everything like that. And all this is going to take is take in the window itself and a width, and then I'm just going to go right away and just call it down here, passing it our window and our width. Alright, so now inside here what I'm going to do is the first thing is going to be pygame.init, which initializes the window, initializes Pygame, and everything like that. And then I'm also going to fill the window with a color, and let's actually make that color real quick. We're going to make a gray, which can basically just be same thing, RGB color value again. We're just going to put 150s for all of these. So this range, for those of you who don't know, can actually be from 0 to 255, and that's just your red, green, blue color values. So what we're going to do is we're actually going to fill this with a gray value. And then we're going to see if this should be it to get it to run. One thing we will have to do still is we'll have to actually update with the new color. And then to make sure this continues to run, we'll just throw a true here, and this should then run. So what we're going to go down here is just do Python, and the name of our file is just going to be binary vid, and here we go. Popped in my other window, but this is what we want. So this is the frame basically. As you'll see, we have a loading bar here, and that's because it's hit this infinite while loop, and it's just processing at this point. So we actually go ahead and just kill that off. Awesome. So now that we have that, we have our basis of our window. Now we need to add is just going to be the actual nodes and the lines in between them. So the first thing we can do is we're actually going to go up here, and we're actually going to create a class called node. And this is going to be the basis for our node. So this is going to be actually what we see displayed and the circles that we saw on that graph that I showed at the beginning of this video. So the first thing we're going to need is an initializer. So that's underscore underscore init underscore underscore self. It's going to need an x and a y value for the location. It's going to need a radius because it's a circle, so you know what size that circle should be. Another thing it will need is going to be a color. And then one more thing we're going to need is going to be a left and right. So each node should have a presence and an understanding of who its children node are. This will be important later on in later videos when we actually go through and do some search algorithms. You'll need to know who your left and right child are. So we can just call those left and right at this point. I'm going to quickly go ahead and initialize all of these, and then I'll be right back. Okay, now that I have all these initialized, what we're going to do is actually go ahead
and start to create some more or less getters or setters. I tend to like to do this just so that it's a little bit easier for me. I'm by trade a Java developer, so it's a necessity to have getters and setters, whereas in Python it's not necessarily that important, but I do tend to like to have that. Now the first method we're actually going to also have is going to be a get location method, so we can actually call this def loc. And what this is going to do is actually going to return back a tuple of the x value and the y value. So this is a little bit easier. It'll be easy for in the future when we actually want to get the location. It'll give us a nice xy value for that. Right now I'm also going to go through that and create the rest of our getters and also some setters to set up the left and right child, the color, set the radius, other things like that. So I'll be right back again. Alright, now that I have these getters and setters, this basically should sum up our entire node that we're going to need. And now that we have our node, we can actually go through and start doing some more of the actual implementation. So the first thing we're actually going to need is a method to actually go ahead and create all the nodes. And I tend to like to have this just so that we can kind of separate the actual calculation of creating the nodes and the drawing of the circles and the lines. So the first thing we're going to do is actually have a method called basically create nodes, and it's going to be passed the width as well as the number of levels in our tree that we're going to have. Then we're going to initialize an empty array and then calculate how many nodes are going to be on the bottom level. And for those of you who don't know levels and trees, a level is basically, if you look at a tree, you could basically see them almost. So you're going to have one node at the very top, which is a root. And then you're going to have a level below that, which is going to have a left and a right child. And then they're each going to have children, which is going to be another level down. And basically there's an equation. So the first where the root is at is considered the first level. And the next one then is the second level and third level and so on. And there's actually an equation to figure out how many are going to be on any level. And that equation is going to be 2 to the power of levels minus 1. And as you may have noticed, I said powers here because 2 stars is actually power to the power in Python. And this works every time. So at the first level, you're going to have 1 minus 1, which is 2 to the 0, which is going to be 1. So you have 1 at the root. And then level 2 is going to be 2 minus 1. You're going to have 2 to the power of 1, which is 2, and so on and so forth. So this is important so that we know how many nodes are going to have to be in the very bottom level. With this then, we can actually figure out our diameter of these circles, which is going to be the width of the screen, and then divide that by how many we're going to have in the bottom level, and then divide that by 2. So the reason why I do this is this right here is actually going to divide and then cut off any remainder. So this is nice. It's called a floor function. It actually allows you to get clean integers instead. And then because we did this, we now know how wide each one of them potentially could be. So this would be the max. So if I didn't have this divide by 2 here, this would be the max value it could be. But I want to cut it in half just so we have a little bit of spacing in between them all. And then we can create a radius variable, which is just diameter divided by 2. So now we need to go through all the nodes and actually place them on our screen correctly. So we're going to create 2 different for loops. One is going to be going kind of the vertical route, so it's going to be for level in range of levels, which is basically going to go through all of them vertically, and then we need to go through them all horizontally as well, which is going to be for node in range. And then this range right here is actually going to be how many nodes are on. This range right here is actually going to be how many nodes are in that particular level. But since this range we actually have starting at 0, we're going to do the same calculation as above, but we're actually going to get rid of the minus 1 aspect of it, just because of the fact, again, that it starts at 0 already, so we're all going to be at 0. We don't want to kind of weirdly calculate this. So this is going to be toe level then right here. So these are going to be our 2 for loops. One's going through the vertical and one's going through horizontally. So also one thing we want to do is at each level we want to figure out where that starting node is going to be. So I'm going to call a variable called start, which is just going to be where that the starting node in that row should be. And all this is going to be the width divided by the tote in that level and then divided by 2. So again, this is very similar, and actually it's the exact same calculation that we did for this diameter up here. But this is only calculating for that final level, whereas this is going to calculate for each individual level. And then all we're going to do is, now that we have this, we're just going to go through and basically add all these to our list that we have. So we're going to create a new node object, and then inside this node object, we're actually going to then place it. So as you see, we need an X, a Y, a radius, a color, and then a left and a right child. So for now, we're not going to worry about the children. We're just going to go through and place them on the screen, and then once we've placed them all, we can go ahead and actually figure out which children are which. So what we're going to do is now create the X and the Y. So both these are going to be pretty straightforward. So we're going to have that starting location, and then what we're going to want to do is actually going to want to do this. So I'm actually going to type it out first and then explain it once I'm done typing it out. Awesome. So what this is actually doing is it's actually showing you, so right here, what this is actually doing is it's actually taking the width value, dividing it by a total level. So we're going to have the width of the screen divided by total level, and then times node. So what this is saying is basically, as you move on to another node, you want to basically add on this distance onto that so that we have good spacing. Because remember, when I first did this calculation, we were figuring out the maximum. So this is basically going to add on that maximum distance between the two of them, between each and every node. And that's what you need to do. And we're going to do something very similar with the y-axis. So it's going to be the width, if I can type here today, and then levels, and then times level plus width. Awesome. So this is doing something very similar once again. So again, like I said, you're going to take this, which is basically going to say, hey, how many levels do you want to have? Multiply it by which level you're on to actually get that spacing correct. And then we want to add on the maximum that we could be at. And then the next thing we want to have after this is going to be the radius, which we already calculated. We want to give them colors of black, and then like I said, we don't care about the left and right children at this point. And there you go. That's how we're going to add on all of our nodes. So now that we've had all of our nodes, again, we've actually created another very popular structure. So this node structure that I have right here is actually what's called a heap. And a heap is a way to store a tree within a list that follows a specific calculation. So for every parent, the left node is going to be 2 times wherever your node is. So say your parent is at 0, it's 2 times your parent plus 1. So if you're at index 0, your left child is going to be at 1, and your right child is going to be the same but plus 2. So then so I can basically put it this way. So I'm going to put an example out right now. So say we have 15, 67, 57, 34, and 12. And these are all just random numbers. But what this is basically saying is that 15 is, say that's the parent. Its left child would be 2 times, and I'll put that real quick for you as well. It'll be 2 times the index plus 1 is the left child. And then 2 times index plus 2 is going to be the right child. So 15 is the parent, then 2 times 0, index 0, plus 1 is the left child, and 2 times index plus 2 is the right child. But now say 67 is the parent. So this is index 1. So 2 times 1 is 2, plus 1 is 3. So 0, 1, 2, 3. So this is that left child and their right child. And that's what a heap data structure is. So that's what this node's variable is actually following. So what we can actually do is go through them and basically just assign their child. So what we're actually going to do is go through the entire list, and then for that entire list, what we're going to do is say that exact equation, 2 times I, which is going to be the index, and I forgot the in here, and then plus 1, and make sure this is actually less than the length of our array. And then we also want to make sure that the value is actually present. So we want to make sure this is what this is doing. This is basically saying, hey, the length of it isn't this, and this value actually exists, because we don't want to just passing if it was none for some reason. We don't want it getting assigned to none again. So we can just do this, set that value to set their left to the value that we get at this location. And then I'm actually just going to copy this because it's going to be very similar then for the right child, except we're just going to change this to be 2, and then 2 over here, and then 2 right here, and we're actually going to say set right. And there you have it. Now you've actually set all the left and right children for all the nodes as well. And now the last thing we need to do is actually just return the nodes. And I do this, again, like I said, so that the calculation of creating the nodes is separate than the drawing out of them. So the next thing we're going to do is actually now draw the circles as well as draw all the lines between the parent and the child nodes. So now what we want to do is actually draw out all these objects. So we can actually go ahead and kind of create a overall function, and we can just call it, we'll just call it draw in this case. So we'll do a def draw. And then this is just going to take in the window, the width, the levels that we want, as well as the list of nodes. And this is going to have everything we need to do. So this is going to handle all of our drawing. So I'm actually going to put in here what we need, and then after I do that, I'll go ahead and create the methods that I'm actually calling within here. So we're going to want to draw the lines, and we're going to pass out the win and the nodes. And then we're actually going to draw the circles, and we're going to pass the window, the width, the levels, and the nodes. And then after that, we're going to want to do the update on the display. And the reason I did it in this order is because of the fact that we want to have the lines underneath the circles. So if I did the circles and then the lines would actually be drawn on top of the circles, and that's not what we want. So now that I did this, let's go ahead and actually create these functions. So I can actually go ahead and I'll do the circles first. So we're going to do def draw circles, and as you see down there, we need to pass the win, the width, the levels, and the nodes. And why we need all this is because we want to actually draw everything. So we need the window to draw it, we need the width to know the width of them, and actually get the sizing and all that jazz that we just did up here. So we're actually going to go for node in nodes, and we're actually just going to go ahead then and do a Pygame draw circles, and then pass it the window. The current node, we're going to want to get the color of it, and they're all going to be black in this case. Node.get the location, because it needs to know where we're going to draw it, and then we're going to need to get the radius because we need to know what size we want to draw our circle. So now we have all that information, and this in and of itself will actually draw the circles for us. Now we want to go ahead and actually draw the lines in between the parent and child nodes. And for this, we're going to do the same thing we just did above by creating the outline of that definition. And then we're going to go for node in nodes. And basically what we want to do is take every parent, and if they don't have a left, if they have a left and a right child, we want to draw the line between themselves, the parent, and their children. So we're basically going to say if node.getLeft is not equal to none, and node.getRight is not equal to none. So that means it has a left and a right child. Then we're going to want to draw a line. We're going to make it a black line just so it stands out. And then this is what we're doing. We're getting the location of the parent, and then getting the left child and getting its location. And we're going to make it a 5 thickness just so it stands out a little bit. I'm going to copy and paste and then just change this to get right. And now we've actually drawn the lines for both the left and right children as well, and they're all connected. And now we just have to do one last thing. And the last thing we have to do is actually just call our draw method from within main. So instead of doing this while true, we actually want to say, hey, let's first, above here, let's say nodes is equal to create nodes, which we need the width and the levels, which we have both of them. I'm actually just going to say levels is, let's do 4. So we're going to have 4 levels on this. And then now that we have those nodes created, in here we can just say draw when width levels is going to be 4. So you know what I'm actually going to do real quick, just create a variable for that just so it's in one place. Awesome. And then we need one more. We just need the nodes, which we just created, and that's nodes. And that is it. And here, if we just go here and do python binary vid.py, you will see that we get a binary tree that has 1, 2, 3, 4 levels. And just to make sure you know that this is actually working, we can actually go in here and change this levels field to be 5. And now if we rerun it again, you'll see that we now have a grid that has 1, 2, 3, 4, 5 levels. And as you see, all of them are smaller, and that has to do with the idea that we're trying to fit all of this bottom level into this width. So one thing you could do if you wanted to make this even bigger is make this not a square, so that this can be a little bit wider and actually fit some more and make sure the circles are a little bit bigger, which will make these more prominent as well. So with that being said, I hope you guys like this. Make sure you definitely subscribe so you can definitely check out the next couple of videos where I'm actually going to go over some binary search algorithms and some different tree algorithms that you can use. So definitely look out for those in the near future. I hope you enjoyed this. Leave a thumbs up, and I'll see you all next time.